we try to use this try to do this chapter 8 graph function. So before that, let's learn about the relation further. Relation between the functions. Okay, so given that in relation we have domain and codomain. Okay, I don't know, in textbook we call codomain or range. Okay, so actually inside here we have object lah. We call object 1, object 2, object 3. Okay, so here we have some image here, image 1, image 2, image 3. Okay, so the relation is, we have 4 types of relation. Either is 1 to 1, many to 1, or 1 to 1. I use 1 to 1, and then 1 to many, many to 1, and many to many, like that. Okay, there are 4 types. So what means by 1 to 1? That means all one object will match with one image. If 1 to 1, that means one object, every object is matched with one image only. So if 1 to many, that means every object will match to different image. Yeah, one object we can match with different image. Okay, let's say we have this one O to I, and then suddenly we have another O to I1, I2, let's say. So this is 1 to many. This is one object to many image. So 1 to many. Okay, so the third one, if exists a graph, a function, no, not function, a relation which is 2 objects that match with one image. 2 objects match with one image. That means we use this one of many to 1, or many to 1, because many objects they match with same image, one image. So this is called many to 1. If in the relation we can see that there are 2 things here, many to 1 and 1 to many, combined together, that means this will be many to many. Many to many. Okay, that means a different object they match with one image. At the same time, we can find that this one object can go to different image. Different image, different object can match with different image. Okay, IMG. Okay, so if you want to memorize, I don't know how to think so. Okay, so but later I will try to explain more about this. Okay, how we identify whether it's 1 to 1, many to 1, like that. Okay, so let's give example for this. Given the order pair -3, we have object -3, -2, 1, 2, 3. We have 10, we have 3, we have 2, we have 3, we have 10, right? -3 to 10 here. Okay, -2 to 3, 2 also to 3, 1 to 2. Okay, this one is 1 to 1, 1 to 1. This one is I don't think it's 1 to 1 yet, because there are two object match with one image. So this is many to 1, many to 1. This one also -3 and 3. Okay, it's many to 1. Okay, so because we have many to 1 here, more than so that means it is many to 1, many to 1, many to 1 relation. Okay, so because we have many object go to one image. Okay, so this many to 1. Can you find that many one object to many image? No, right? So here we cannot say that it is a many to 1, 1 to many, or many to many lah. Okay, so beside we also can try to do like this, because here we have many. Okay, many to 1. So if we have combination from the others, this one many, this one all in one only, so 1, so many to 1. So we'll use a cross relation, see the cross one. Okay, so later we'll see the example. Okay, state the relationship between variable for each following situation. A calculator costs 48 ringgit. Brian bought X calculator for Y ringgit. That means this one, X. Okay, X times 48 equal to Y. So if X increase, Y also increase, 1 and 1. Okay, so this is 1 and 1 relation, 1 to 1 relation. Why I use a red pen? Hiya. Actually I need to use the blue pen. Later I need to check answer together, right? So B, Tanesh cycle with a speed of S km/h for T hour and cover the distance of D km. Okay, this one we need to think first. Speed of S km for T hour, cover a distance of D km. For T hour, D equal to S over T, right? But this one, I don't know which one is a T, which one is the object, which one is the image. Hiya, so how much? I skip this first. The area of a trapezium is A. The area of trapezium is A. Huh? Why we have many A equal to in terms of X and Y. In terms of X and Y. But I don't know. What's the relation? Why this question so difficult? The volume in cm cube of a prism is V. This is also V in terms of X and Y. So this one I cannot identify. So felt sorry. Later I see the textbook. Okay, so let's go to question 3. Identify the dependent and independent variable in the following relationship. So Y depends the X because X, if X change, Y would change. Okay. U change, V also change. So which one is dependent? Which one is independent? Independent variable means that V and U are dependent. 30 is independent, right? Constant variable. No? So this is the dependence. This one is independent. Later I check this answer whether it's correct or not. This constant is a independent variable. Is classified independent or not. Given the function v equal to 9 plus 2t minus t squared, find the value of v when t equal to 0, t equal to 3, t equal to 7. Different substitution. Okay, so let us see. When t equal to 0, that means v equal to 9. When t equal to 3, so let's substitute 3 minus 3 squared. So we'll get 9 plus 6 minus 9. We get 6. C when t equal to 7, plus 2 times 7 minus 7 squared. So we'll get 14 plus 9 minus 49. So here I will get the answer 9 plus 14 minus 49, negative 26. yeah, negative 26. Okay, so this one state whether each of the following is a relation, is a function or not. So that means to identify, to make sure it's a function, make sure we have an object, all object, okay, all object in the domain, all object in the domain has only one image, has only one, only one, must have one and only one, must have one and only one. Each object must have one and only one image. So let's say we have ABC. This is the object in the domain. ABC, we have image, everything is one, so it's a function. Yes, it's a function. So it's better we try write out it's a function or not, it's not a function. Okay, so here PQR also have every object have one image, so it's yes, it's a function. This one, not all the object has an image, because the file didn't have image, so it's no. All the object has one image and only one, this one yes. Okay, although this is no object, but we still can classify that it's a function. Okay, this one, all object has one image, every object has one image, so this is a yes. All object, this one has one image, but this one is two image already, so this one is no. So let's say this question, 0 to negative 2, 2 to 2, 5 to 23, all different object, okay, connect with only one image, so pair with only one image, so this is yes. If let's see 3, 4 and 4, this one we have 2, 4, two object, one object connect with two image, so this is no. So this one, negative 1, okay, we have 1 also have, and 3 also have one object, one image, so this is yes. Okay, but because we have a 2 and 0, so I don't know whether this in graph, right, whether 2 and 0 is in domain or not. If it's in domain, that means it's no lah, but without, this is not in domain, that means yes, because we have the negative 1, 1 and 3 as a domain. Okay, so let's say see which part or which object in domain. So if this is in domain, that means no. If this is not in domain, that means we have all object have the image, so it's yes. So this one, let's say we have 1, 2, 3, 4 is in domain, so 1 we have 1, so but 2 we have 2 answer here, so it's no already. Okay, don't see anymore lah. From 1 to 2, yeah, 2 have one image, 3 also have one image, 4 and one image, and 6 the objects have two objects. So although we have one image, okay, share with two objects, but every object, okay, they pair with only one image, so this is yes. Okay, so in conclusion, to make sure the relation is a function, we have two relation can be categorized as a function. One is one to one and many to one. Okay, if one to many, let's say one to many is not already, because one object to many image, this is not, and many to many, this is complicated one, so this is not. So we have these two conditions, so can categorize as is a function, not categorize, can classify is a function, it's not a function, it's not a function. Okay, so just now when we see this one now, let's compare. Okay, so because all one to one, so it's one to one. So this also all one to one, one to one. This one, because this one doesn't exist any image, so I cannot identify. Okay, so this one also one to one. Okay, this one we have many object go to one image, so it's many to one. Okay, so how we try to see, or maybe you can see that many to one here, many to one, so all in one, one, okay, also can. Okay, so this one, one object go to many image, and one image come from many object, so it's many to many. Okay, so I will see like that also lah. Can try to do like that. So each of the following is a graph with function x squared plus 1. So this one you need to you can try to see the pattern of the graph. You can try to see the shape of the graph shape. We have several types of graph shape. Okay, which is the straight line. This is called linear function, linear graph. Okay, with the linear function is built by the linear function. So graph maybe you can call function lah. If the function we plot the graph, we call linear graph. So if it's come from the linear function, we have fx, or we use a y equal to x plus ms plus 1. This one is a pattern, ms plus c is a linear function. This is example type of linear function, the format. Okay, we just have a power of 1. The x is power 1. So if we have the shape like U shape, okay, or the U but inverse. Okay, sometimes we have the position like that, upper here, or we try to use this, or here. Okay, so this one is a quadratic function, made by quadratic function. So it's a quadratic graph. Okay, it's a quadratic graph made by quadratic function. So this one are x and y, between x and y. Okay, so next, another one, we also have this one. If I have a graph up and then suddenly down and up, or if I up and then peacefully and then out again, up and then constant, uniform, and out again. Okay, or I down, constantly down again, or down, suddenly up and down again. This one is an example of cubic graph. Okay, it's made by cubic function. So what is cubic? It means we have 3 lah, a power of 3. So if we exist a power of 3 function, the variable we have power of 3. Okay, so this is a cubic function already. Start from cubic function. So you can try to explore using the Desmos calculator. Okay, so later we also have another 2 function, which is y equal to 1 over x and y equal to 1 over x squared. So there are another 2 different functions here. One is the function will like that. Okay, another one, the function will like that. X squared, all in positively. The y is positive. Okay, so this is the pattern of the graph. So let's see the pattern of graph. So when we see the pattern of graph, this one is a quadratic. Okay, this is a quadratic. This one is a cubic. This one also a cubic, a type of cubic graph. And let's see x squared plus 1. If x equal to 0, y equal to 1, right? X equal to 0, y should be 1. So let's see why is it positive not. This one positive 1. This one negative already. Okay, so negative value, so this one not. Okay, so answer is A. Okay, so you can see the pattern of graph like that. Okay, so the table below show the value of variable x and y of the function. So let's try to determine the value p and q. So how we use calculator? So this here I try to use calculator. Can you see my calculator? Cannot. Cannot, right? I don't know. You whether can see or not. Oh, maybe I try to setting first. Okay, now okay already. Okay, so we'll see. If you want to input or key in this function, so if you want to write down y also can, don't want also never mind. because I just want to find this one, the value of this. So I use 2 alpha x square, okay, plus 8x, use alpha and use this, minus 24. Okay, calculate when x equal to -2. Let's see, check whether answer correct or not. Answer is 32, -32, yeah. If -1, so it's like 30, so it's 30, -30. If 0 is -24, yeah, correct. If 1 is -14, yeah, correct. If 2 is 0, correct. When the x is in 3, so it's 18. So let's try to use p minus q. P is 18 minus q is -30 positive, so answer 48. Okay, so answer 7. Okay, question 8. Try to construct a table value of a function y equal to 5 plus 4x minus x squared. Okay, so we construct a table. So in construction, a table construction, we have x and y. So let's see what's the value of x. So it's within -2 until 3, between -2 until 3, so include -2. So maybe you can use the different 1 in different. Okay, so 0, 1, 2, 3, done. So this one I will not write already, so I will erase. Okay, so let's use this function y equal to 5 plus 4x minus x squared. Okay, so we no need to substitute one by one, just key in this formula and then we use calculate. When x equal to -2, it's -7, answer. The y is -7, so this function is -7. When s is -1, so the output is 0, y is 0. When s is 0, output is 5. Yeah, so I will use this one. Okay, 5. So if x is 1, y is 8. When x is 2, y is 9, and x is 3, y become 8. So I see this graph will become like this. Upper, then it start to drop down. So this is an example of quadratic function. So later we try to drop like that, so we can estimate what's the pattern of the graph. So it's a U shape. Okay, it's a mountain shape. This one, mountain shape. So given function with a point in a point 2 equal to -2p and 3q lie on a graph function. So find the value of p and q. Okay, so here we have when x equal to -2, when s equal to 3. So what's the p and q? So let's use a function 2x power of 3, right? Minus 5. So calculate when x is -2, is -21. So p is -21. When s equal to 3, so the q is 49. Okay, so just substitute and then write the answer. Okay, but if you're using answering a question or this paper 2 or session C, okay, I think we should try to substitute manually. So let's say we have y equal to 2x cubed minus y. If I substitute -2 and p, substitution -2 and p, we'll get p equal to 2 cubed minus 5. That means we will get -8 times 2 -16 minus 5 is -21, right? Okay, so when we try substitute 3 and q, we will get q equal to 2 and 3 power cube, 3 cube minus 5. We will get 18 minus no, it's 27 times 2. Okay, 3 times 3 9 times 3 27 times 3 times 2 54 minus 5, it should be 49. So answer is this. We can make conclusion like that. Okay, so if the mark if you give a mark is 4 mark, that means more than 2 mark, we need to write down the solution step already. Okay, let's go to question 10. It's a graph plotting. So I have a graph here. So we have using the scale, or try understand what's the question 1. Using the scale 2 cm to 1 unit of x-axis, 2 cm to 5 unit of 1 y-axis. Label the x and y-axis. We need to label also. Okay, the first thing is we try to before we try to plot, make sure we see the condition, see the range of the x-axis and y-axis of y value. So let's see the x. We have -4 to 3. Okay, that means we can start in center also can lah, because maybe they're already in balance. Okay, but the y, we start from -21 to the maximum is what's the number? 9, not 7. It's 9. That means we need to maybe we can do -25 to 10. We can plot the graph within this range. Okay, so in x-axis, okay, so we can try to draw the y-axis first here. So maybe I draw the graph here. When x equal to 0, so I try to move a little bit. No, I don't want this image. Why the image so big? Okay, so I try to move them. Why so big? Okay. Okay, so after you draw this x equals 0, so maybe you can try to see the y. So we start from -25. Let's say this one, the graph, the size is, this one is 2 cm. In your graph, the small space or small square grid is 2 mm. So you use the 2 mm grid. So in this, the big square, you will get 2 cm. So within 2 cm we have 5 units. So you can try to draw lah. 10, -10, -5. This one 0 already. So it's 0. You can try to draw the x-axis. Okay, so this is x. But I want to move a bit because I want to extend this. One, 2, 3, 4. Okay, good. Because here we have 1 to 3 only. So here we have 4, -4. Okay, so that's why I try to move a bit. So we have 5. We have 5, and you see you have 10 because maximum is 9, right? So maybe we can add another 15 here. So you can close it as a y here. Okay, you must label. So here if 1 4 also can, but you will not state the label this graph already. Okay, so we have this graph. We try to plot. -4 is -21. Okay, -4, y -21. -21 is where? So it's here. So we use a cross. Okay, use x cross to plot the graph. Okay, when -3 is -11, 2 square grid or below, and then -2, -3. If -1 is 3, if 0 is 7, if 1 is 9, 9 is here, 2 also 9, 3 become -7. So how about the 4? What do you think the 4? The value of 4? Maybe it should be -3 with same with here, right? Same with this. Okay. Okay, so we'll stop like that, and then try to connect the dot together. So maybe the graph like that. See the pattern, come smaller. I cannot see this one. You try to draw it smoothly. Draw it smoothly. Draw it smoothly. I don't want to see this graph. Like that. Okay. So maybe I try to draw smoothly. Smooth. Okay. So must have some curve shape. Okay. Must be in curve shape. Or not in straight line. Okay, sometimes I see that some students they try to draw a straight line between the point and 2 point. So don't want. So we try to mesh in curve shape. Draw beautiful. Draw it beautifully. So we can after draw plot all the point already. Draw the graph already. So draw the graph that means we connect all the point lah. Plot that means we use a point or dot. So there's 2 marks, there's 1 marks. This one see the question maybe 1 mark or 2 mark like that. Okay, so the graph already done. So the another question also same. Okay, the first thing we need to understand check what's the question 1, the scale 2 cm to 1 unit and 2 cm to 5 unit. Okay, next we check what's the maximum and minimum of the range for x and y. Okay, so you can see that -3 to 3 center lah, the x-axis center already. No, the y-axis center already. If x equal to 0, right, x equal to 0, y-axis is center already. So first time we try to draw the y-axis first. Very easy. Try to draw the y-axis first. Okay, so it doesn't mean that our graph 0 origin must be in center because it's based on the range. So here we have -3 and 37. That means for y-axis the negative value is smaller, have a small space. That means we just give the space like that. Okay, give a space like that. Or you want to check whether it's 40 below. So you start from 40, 35, 30, 25, 20, 15, 10, 5, 0. So in 0 you try to draw this x-axis, and then you start from -5, -10. So 15, 10, 5, 15, 20, 25, 30. Sorry, it's not enough. I thought that 40, 35, 30, 20. Sorry. Why I repeat the 20? So we have 25, 30, 35, 40. So usually the labeling is from here in left hand side, but now I try to right hand side. It's okay. If for x-axis usually is down, it's bottom. We draw in bottom. Negative. 1, 2, 3. I think no need to 4 lah. So if you want to 4, okay. No need to 4 also can. So we start from 37. Plotting graph. Start from 37. 37. Second one is what? Second one 21. Drop to 21. 21 is here. And then 9. Wow, drop very fast. Drop to 9. And then next is 1. 1 is here. If 1 is -3, so check -3. Where is -3? Here. 2 also -3. And 3 is 1 already. 1 is here. Okay, so we can plot the graph and then plot the point and then try to draw the graph. This one, make sure when you try to mesh or draw the graph, you must pass through the point. try to pass to the point. Okay, like that. Okay, so the graph will be like that. And then I forget to put the y here. Okay, so in the graph, right, sometimes they ask you to find the value of x if y equal to 8. Let's say, so if y equal to 8, so maybe you can try to draw the line here. 6, 7, 8. Yeah, 8 is here. If y equal to 8, so try to draw the dot line and check what's the value, what's in between 3 and 4. So this one, the x is 5. That means maybe you can draw write down the coordinate 0.5, 8. So that means our x is in 0. Oh, sorry, not 0.5, 3.5. Sorry. 3.5 actually. 3.5. 3.5. 8. Okay. So you can try to write down 3.5. Is it only one answer? So you can check back, look back, because sometimes we have two answer. So example for this, for left hand side we also have another answer here. So don't just give the one answer only. See, also we have one. Okay, so you can get the s is equal to negative 3.5 also. So actually we have two answer, negative 3.5. These two answer. So don't just give one answer. Okay, so see what's the object for given the image A. This one also, when y equal to negative 1. So let's see y equal to negative 1. Negative 1 is here. Okay, because the scale is negative 2, negative 4. So negative 1 is center, negative 1. So let's draw the dot line. Okay, is quite near to the here, quite near to this. So for this one, is the center for this. Okay, so this is s equal to negative 2.3. Okay, 2.3. So this one is s is equal to 1.4 estimation. Okay, it's near to 1.4. So you write down like this. So s equal to negative 2.3, s equal to 1.4. We have to answer. Don't forget. So for last two question, this one can check. Complete the table for equation by writing down the value of a when x equal to 4. So let's see, x squared plus 3x minus 2. So x squared plus 3x minus 2. We have 16. No. We didn't calculate yet. So don't just write the 16 here. When x equal to 4, just now we have 3, 16 is correct. But x equal to 4, okay, answer is 26. So we complete the table below. Okay, so next, by using the scale 2 cm to 1 unit, 2 cm 1 unit, and 2 cm to 5 unit, and check s axis is start from 0 to 5. That means our s axis scale, right, negative value would be smaller size, okay, smaller space until the 5. So for the y axis start from negative 2 and the maximum is 38. So our y also becomes smaller. So maybe we can start from origin here. Okay, start from origin here. So let's say I draw this one here. Yeah, and then for the x here. Okay, there's the x. We label as x, and this here we label x, not the y already, because here is a. So we'll label as A. So we try to plot, draw the scale. 5, 10, 15, 20, 25, 30, 35, 40. Because the maximum is 38 here, we use the 40. So -5. So this -1, 0, and start from 1, 2, 3, 4, 5. You want the 6 also can. Okay. So we start to plot the graph. Okay, so now the first is -2. When x equal to 0, it's -2 here. If x is 1, it's 2. If x is 2, it's 8. Well, A is 8. 6, 7, 8 is here. When x is 3, it's 16. When x is 4, 26. When x is 5, 38. 38 should be here. Okay, so that means 2 unit, or every 2 unit, 1 increase 1 unit. Every 2 square increase 1 unit. So we need to see like that. So then we plot the graph, draw the graph. Start from the 0 to here, becomes more bigger, become bigger. This one not so happy. Try to redraw. Okay. Not beautiful. I start from here. It's not beautiful also, because it didn't touch the point. It's not beautiful. Okay, be like that. Okay, so you try to draw. Next, the question asks about what? So if a question asks like this, 0 until 5, if you draw as this one and 6, it didn't deduct your mark, but we need the object. The object is between 0 until 5. Okay. Can put right here. So the next one is -2 until 4. Okay, we try to draw. Okay, so this one I will not answer it already. So give you do it yourself. Okay. So thank you so much. I would see the no thank you yet, because I will see this one. Let's see the relationship, whether in textbook is it asked about the relationship. No. Or the pair. Okay. It didn't mention, didn't teach us how to see the relation. Oh yeah. So the first question actually is this one, question 2, very hard. If let's say the area is A, is a constant, If the a is a constant, that means it's fixed already. Okay, constant. That means we can try to move the x and y. No? We can try to move the x and y. Okay, so let's say we have if x is positive, so how about the y? Because it's x and y, they are in linear, so that means it's 1 to 1 1 to 1 1 to 1 1 to 1. So for this 1 to 1, for this, if a prism is the v, so x plus 3 times y plus 1. Okay, so we already have x, we already have y, we already have x and y. Oh no, very difficult a bit. It's v, so sometimes we try to move the x and y. Maybe we want to y equal to, so we have a x minus b minus x and y equal to 1 over x. Okay, so this graph actually sometimes we have two value already lah. Two value already. 2x with y. So maybe you can try to check whether the graph pattern is like that, you know. So we can check. So actually it's let's see the graph. I constant the 78. Okay, minus x 1 minus x. S cannot be 1 because if not it's infinite. It's negatively. S cannot be negative value. Oh, y also cannot be negative value. Okay, so let's check the answer. So this one not in textbook, you cannot identify. I also didn't realize that. State the relationship between the variable. So the answer is given like that. Y equal to 48x. Okay, it didn't say that didn't need us to state the relationship, the type of relation. So why I use the type relation? So this one is area. Okay, area equal to use the formula lah. That is why I think so much. So a is equal to, we try to use this 1 over 2, we have x plus 1 plus 2y plus 3 and times 18. That means we have 9x plus 2y plus 4. Conclusion, this one. Okay, so next one, the b actually is t equal to x over t lah. Okay, x over t. This one just now I do correctly already. Then the next one, this one. Okay, so we try to use this one. V equal to x times 3, y times 1, y plus 1, and then 6. So it didn't say you want to use the because we need to take a half because it's a triangle. So it's 3 x plus 3 y plus 1 also can. So we'll stop right here. But the question, the answer here given, we expand this, factorize, so also can. Question 3. So why is the dependence? X is a non-dependence. Oh, like that lah. I don't know. So U is non-dependent, independent, V is a dependent. So it's a dependent. These two, X and the U, is independent. Yeah. That's why we have X and Y, right? So for the x-axis, that means the thing we can try to change it, and then we'll have a result of y. So the result is a depends on this. The result is a depends on the value of x. So this one correct. This one yes, no, yes, no, yes, no, and then no, yes. Yes, no, yes. A. Donkey. Oh, just on question 1, I haven't do it. It's C, yeah. So negative 7, 0, 5, 8, 9, 8. P is negative 21. Q is 49. So when plotting the graph, you can check the answer here lah. Okay. So if possible, we skip this, the one, to prevent some strict examiners, they will really try to deduct your mark. Okay, yeah, correct. And then this one, the graph also. So maybe we skip this negative 4 to 1 draw it. Why never mind? Why never mind? Why we can drop, do more also can, never mind. Okay. Okay, so maybe we don't need to draw this. No need to write down. Although we have extra space here, so no need to label. So maybe you can try to draw this graph, so you get this one like that. This graph like that, in this pattern. Okay, so try to draw it. Okay, thank you so much. I will stop.